Hi, and welcome to the second video in the series of lectures in the context of ICSE 2026. This is Yash Singh Jha, and I teach physics at Boone English School. So, in this lecture, I would like to take you through a few problems that have already been asked by the council, by the board in class 10 examinations. The purpose of this video is not to produce or to promote the usual ratification or rote learning that usually students opt for, but to infuse a thought of how to think, yeah, and to infuse that sense of curiosity and genuine love for the subject. Yeah, so let's get on with it. I hope you have already watched the previous lecture, which was covering the theory for the entire chapter force. Let's get on with it. So the first question is for 1 marks. Yeah, and the question is, a door lock is opened by turning the lever of handle 0.2 meters. If the moment of the force produced is 1 Newton meter, then the minimum force required is. Yes, so it's pretty simple, pretty straightforward. We know that torque is force times the distance between the line of action of the force and the axis of rotation, or the point of rotation about which the torque is being calculated. Yes, so now they have said that the length of the handle is 0.2 meters. If the moment of force produced is 1 Newton meter, so we know that 1 Newton meter is force times the distance. The distance of a door lock can be anything between 0 and 0.2 meters, right? Because the handle is at 0.2 meter, but I can apply the force anywhere, yes, from 0 to 0.2. But we know that the force required will be minimum only when the distance is maximized. The distance between the point of application of force, the line of action, and the center of rotation, or the point about which the rotation takes place. So F into 0.2 meters. So F required, which is the F minimum also, in this case turns out to be 5 newtons. Yeah, so you must be noticing that in this lecture I am not writing the answers as you are supposed to write in board examination. In board examination you have to be, of course, crisp and concise, but also it should contain all the things that you want to convey. Yes, it should be elaborate, it should be elaborate yet crisp, yeah, yet concise. Here I am just telling you the thought process of how to think, how to approach the subject. Yes, okay, so this is how you do it. Moving on, let's go to the second question. A force F moves a load from A to C as shown in the figure below. For the calculation of the work done, which of these lengths would you use as the displacement? Yeah, so this is from the chapter of work, power and energy. So the solution is along the direction of force, yet, so the answer comes out to be 5 meters. We will discuss it when I complete chapter 2, that is work, power and energy. Moving on, clockwise movement produced by a force about a fulcrum is considered to be, we know, right, the nomenclature or the sign assigned to clockwise moments is negative, and the sign assigned to anti-clockwise moments is positive. So depending on that, based on that, we can answer clockwise moment produced by a force about fulcrum is considered to be negative. When a stone is tied to a string and rotated in a horizontal plane, the tension in the string provides dash force necessary for circular motion. Yes, so looking from the top, if this is the stone, it is tied on a string and rotated. in a circle, right? So the force necessary in a circular motion, for a body to undergo circular motion, is, we know, it is called the centripetal force. In this case, the tension in the string is providing the necessary centripetal force. Yeah, so the answer is centripetal force. Yes, so the similar example can be the earth going around the sun. If this is the sun and this is the earth, the centripetal force is provided by the gravitational force of attraction between the sun and the earth. Yeah, one more example can be an hydrogen atom. So there is a proton, a nucleus, and the electron. So the electron goes around the nucleus, and the necessary centripetal force is provided by the electrostatic force of attraction between the proton, the nucleus, and the electron. A non-uniform beam of weight 120 Newton pivoted at one end is shown in the diagram below. Calculate the value of F to keep the beam in equilibrium. So this is for 2 marks. Yeah. So what do they want? There is a beam, yeah, of weight 120 Newton, and they have also managed to show us where the center of gravity is. The center of gravity is here, and the weight is 120 Newtons. Yes, the pivot is at point O. Pivot is basically the point of rotation where the body rotates. Yes, calculate the value of F to keep the beam in equilibrium. We want the beam to be in equilibrium. That is, there should be no resultant moment or the resultant torque on the body. Yes, let's calculate the torque currently. Torque due to weight is how much? The weight of the body, that is 120 Newtons, times the distance between the point of application of force or the line of action of force and the point of rotation. So this is the distance, which is 0.2 meters, which turns out to be 24 Newton meter. The torque due to F turns out to be the force F times the distance between the line of action of force and the point of rotation or the axis of rotation, which is 0.8 meters. One more thing to note is the direction of torque. Torque is a vector quantity, right? So torque due to weight tends to rotate the body in a clockwise sense. So this is a negative quantity for the first one. In the second case, torque due to F tends to rotate the body in an anti-clockwise movement, in an anti-clockwise sense. So it is a positive quantity. So in order to have the beam in equilibrium, the resultant torque should be 0. So if I add all the torques, the resultant should be 0. So let's do it. 0.8 F from here plus it is negative 24 is equal to 0. I hope I am clear. I am adding all the torques required. So I am adding torque due to F, which is 0.8 F, plus torque due to the weight, which is minus 24, is equal to 0. It should be 0 since the beam is in equilibrium. So F is 24 upon 0.8, which turns out to be 30 Newton. Little bit of common sense applied to your theory. What theory do we use here? We use the definition of torque. What is torque? Torque of a force about a point is the multiplication of the force, the magnitude of force, multiplied by the distance. What distance? The distance between the line of action of force, and the axis of rotation or the point of rotation. D. This is the only theory we used. Torque again has direction. Anti-clockwise is positive and clockwise is negative. And if the body is in equilibrium, the summation of all the torques on the body should be 0. So we took the torque due to weight, torque due to F, the only two forces acting on it, and we summed it and equated it to 0. And from there we attained F. Define center of gravity. A hollow ice cream cone has height 6 centimeters. Okay, let's first define the center of gravity. It is for 3 marks. These two questions is for 3 marks. What is the center of gravity? Center of gravity is a point about which the entirety of the weight acts. Yes, it is a point about which we can assume the resultant of a force to act. Yes, that is the center of gravity. What is it? Center of gravity is the point of application of the resultant force on a body due to Earth's gravity. Yes, where the resultant of the entire weight of the body acts. That is the center of gravity. Yeah, write in your own words. The same concept can be articulated in different words. Yes, but the main core concept remains the same. In board exam, you are free to use the language of your own, but the core concept should be correct. If you have understood the topic properly, nothing should be a problem for you. Yes, a hollow ice cream cone has height 6 centimeter. So I have a cone and they say that the height is 6 centimeter. So this is 6 centimeter and it is hollow. Where is the position of its center of gravity? From the broad base. So here is the base. So where is the position? We know that for a hollow cone, the center of gravity lies along the axis at a height of h by 3. Right? So this is the position of center of gravity. Yeah, h by 3 means 2 centimeters. So 2 centimeters from the base along the axis, that is the place of center of gravity. That is the position of center of gravity. Yes. The second question is, will its position change when it is completely filled with honey? Yes, it will. Center of gravity depends upon what? 2 factors. First, the shape and size of the object. Second, the distribution of mass. The distribution of where the mass is there. Yes. So if it were a uniform cone, completely filled cone, then we know that the center of gravity would be at, again, along the axis, but at a height of h by 4, lower than in the hollow case, because we have filled the cone. Yeah, for a hollow cone we know that center of gravity lies at h by 3, but for a solid cone which is filled, completely filled, it lies at a height of h by 4 from the base along the axis. Yes, so the position is, answer is yes, only yes. Also, one more thing to note is, more you elaborate, unnecessary elaboration will make the chances of making mistakes more. Yeah, so it will make you more, it will make you, the chance of you making mistakes will increase. So try to be as direct as possible, as to the point as possible. So here they have just said yes or no. So you just write the answer yes or no. So the answer is yes. No need to provide any other explanation. This explanation that I gave to you was just for your understanding. In the board exam, you just have to write yes or no. Next question. What is the position of center of gravity of a triangular lamina? Yeah, as you must have already known or read, if you have any triangle, where is the position of its center of gravity? It is at its centroid. What is centroid? the intersection of its medians. Medians means, median is a line that joins the vertex to the point on the edge, on the opposite edge, which divides that edge into equal parts. Yeah. So this part and this part is same, and similarly this part and this part is same. So this point is called the center of gravity, which also happens to be the centroid of the triangle. Yeah. So what is the position of center of gravity of a triangular lamina? The centroid. When this triangular lamina is suspended freely from any one vertex, what the moment of force produced by its own weight in its rest position. What do you mean? If I take this triangle and I suspend it from any of its vertex, I place it here and I let it rotate about that point, we know that the center of gravity will try to be as low as possible, right? So if this is the triangle and it is about the vertex, I have made it free to rotate. It may rotate left or right, anywhere. Yes, so center of gravity will be along this line. Center of gravity wants to assume the lowest position possible. The lowest position possible will be always along the line, directly beneath the axis of rotation or the point of rotation. Yeah, what is the moment of force produced by its own weight in its rest position? The moment of force would be what? 0. Why? Because torque is force into distance. What is the force? Force is the weight. But what is the distance? Distance is the distance from line of action of force to the center of rotation or the axis of rotation. Here if you see the weight, the line of action is passing through the point of rotation. So the distance would be 0. So torque produced would be 0. Yeah, not just for a triangular lamina, for any object in the world. If it is free to rotate about any point, then the moment of force produced by its own weight will always be 0, because the center of gravity will always be at a point directly vertically in the line of the center of rotation. The next question, again, I am not doing these questions to tell you how to write in the exam. I am doing these questions just to inculcate a value for thinking, how to think. Yeah? If a new question suddenly comes in exam, what should my thought process be? Yeah, how should you analyze things around you? That is what I am trying to teach you. Diagram shows a wheel O pivoted at point A. 3 equal forces F1, F2, F3 act at point B on the wheel. Which force will produce maximum moment about point A? Very simple. Torque is what? Torque is force times the distance. Now the magnitude of force is same. F1 is same, F2 is same, F3 is same, right? They are equal forces. So what can change? The distance. Again, what is the distance? Distance between the line of action of force, the line of action of force and the point of rotation or the axis of rotation. So what will we do? Let's zoom into the picture and we'll analyze each case. So the line of action for force 1 is this. The moment or the distance considered in the calculation of moment for F1 will be this distance d1. Yes, the line of action for force F2 is this. The minimum distance from point A is something like this, the perpendicular distance. It is d2. The line of action for force 3 is something like this. The minimum distance will be this, d3. Which among these is the largest? Yeah, d1 is clearly the largest. So the distance of point A, which is center of rotation, to the line of action of force 1 is the maximum. So the torque produced, the moment produced by force 1 will be the maximum, will be the greatest. Yeah. So which force will produce maximum moment about A? It is good, force 1. Give a reason for your answer above. This entire thought process you have to present it in a concise, crisp way. You start by the definition of torque, the moment, which is what? Force times distance. Yeah. After that, what you do? You tell them force is same, since F1 is F2 is F3. What can change is the distance. What distance? Distance of the line of action of force to the center of rotation or the axis of rotation. Yes. And then you demonstrate, create D1, D2 and D3, and then analyze which is the largest, which is the biggest, and then choose that as your answer. Moving ahead. What should be the angle between the direction of force and direction of displacement for work to be negative? It's again a question for the next chapter, the work, power, energy. The formula for work is F dot S, which comes out to be Fs cos theta. Yeah. F and S are the magnitudes. So the only thing that can make it negative is cos theta. Cos theta is negative when from 90 degree to 180 degrees. Yeah. So in this interval of angles, the work done would be negative. Or if the direction of force and direction of displacement make an obtuse angle, it will be negative. We will discuss it in the next chapter in detail. A meter scale of weight 50 gf can be balanced at 40 centimeter arc without any weight suspended on it. Yeah, so it's not a uniform scale, right? For a uniform scale, it should be balanced at the 50 centimeter mark. A meter scale means it should be of 100 centimeter or 1 meter length. So they are saying, let's say if this is the 0 mark and this is the 100 centimeter mark, they are saying that around the 40 centimeter mark, it is balanced. If I place a balance here, the meter scale will be balanced. Yes. Now they are saying if this ruler is cut at its center, then state which part of the ruler will weigh more than 25 gf. Right. Now they are saying that it can be balanced at 40 centimeter mark, which means the weight of this left part and the weight of the right part, the moment produced by both the parts will be same. Yeah, the center of gravity is here. Yes, so the weight of the left part and the weight of the right part will be same. Yes, so the left part weighs 25 gf and the right part weighs 25 gf as well. If this ruler is cut at its center, then state which part 0 to 50 or 50 centimeter to 100 centimeter of the ruler will weigh more. They are saying if I take axe and I cut it at the 50 centimeter mark, at the 50 centimeter mark I cut it, and then I evaluate these two parts, this part and this part, 0 to 50 centimeter and 50 centimeter to 100 centimeter. So now they are saying which of these parts will weigh more. Which will weigh more? Yes, you are right. The left part will weigh more because this itself was 25 gf. I am adding weight on it by increasing or cutting it at 50 centimeter. Yes, so 0 to 50 centimeter part of the ruler of the meter scale will weigh more. What minimum weight placed on this meter ruler can balance this ruler when it is pivoted at its center? So I take this meter scale like this, and I want to pivot it at its center. I want to pivot it at its center. Center means what? Center means 50 centimeter mark from either side. Yes, from this definition that it can be balanced at 40 centimeter mark, we know that the center of gravity is at 40 centimeters. Yes, if it's not clear, please visit the lecture that I gave earlier or this video itself, or just ask me personally. Yeah, center of gravity is at 40 centimeter mark. What is the weight? The weight is 50 GF, and this is 40 centimeter. Now they are saying minimum weight placed on this meter ruler. Yeah, so the tendency of this ruler is to turn anti-clockwise because of the weight. Yes, minimum force applied would be where? Here, downwards. Yes, let's say the force is F. Why minimum? Because here the distance is maximum 50 centimeters, either here or here, wherever, either at this end or at this end. Apply it as far away from the pivot as possible. So F minimum, we want to balance the torques, right? So what is the torque due to the weight? Torque due to weight is what? Force 50 GF times the distance. What is the distance? What distance of line of action of force to the point of rotation? So it comes out to be 10 centimeters. 50 minus 10. Yeah, 10 centimeters. What way? Anti-clockwise. Anti-clockwise. Anti-clockwise means positive. Correct? Torque due to F. Why is F downwards? Only then will the meter ruler balance itself, right? F is producing a clockwise effect. Only a clockwise effect can negate or cancel out a anti-clockwise effect. So torque due to F will be F into 50 centimeter clockwise. Clockwise means negative. Correct? So it should be in equilibrium. How do we do it? The sum of all the torques should be 0. There should be no resultant torque. Let's do it. 500 GF centimeter plus torque due to F, which is minus 50 F centimeter, is equal to 0, which will give you F is equal to 10 GF. So the minimum force required is 10 GF. I hope it is clear. If not, please go back in the video and rewatch this question again. It's a good question that clears a lot of concepts. Again, this is such a simple question, right? Define moment of a force. We have been doing it again and again while solving the question. What is moment of a force? Moment of a force is the quantification of the turning effect of force. Yeah, how much turning effect can a force produce, right? And what is it? How is it defined? It is defined as the magnitude of time. The moment of a force is defined as the multiplication of force times distance. What distance? Again, the distance from the line of action of force to the center of rotation or the axis of rotation. And that is the definition of moment of force. Again, what is the SI unit of force? It is Newton. SI unit of distance, it is meter. So the SI unit of moment is Newton meter. What is the CGS unit of force? Dyne. CGS unit of distance? Centimeter. Correct? So the CGS unit of moment is Dyne centimeter. What is the relationship between SI and CGS unit of moment of force? We know that 1 Newton meter, let's convert Newton to Dyne. We know 1 Newton is 10 to the power 5 Dyne. And 1 meter is 100 centimeters. So 10 to the power 5 dyne centimeter. So the relationship is 1 Newton meter is 10 to the power 5 dyne centimeter. Again, I am emphasizing this is the way that thought progresses. Yeah, it's a way in which a rational, intelligent thought progresses to solve a question. Yeah, you focus on that. Once you get hold of it, any question you'll be able to solve. Define couple. What is couple? We studied it, right? Couple is the arrangement of two equal and opposite parallel forces. It should be like, for example, in a steering, right? It should be equal and opposite. If force F here, force down here. Yeah, equal and opposite forces acting along parallel lines. It should be parallel at different points. It should not be at the same point. There should be some distance in between the force. Yeah. Then what is produced is called a couple. Let me repeat. An arrangement of two equal and opposite forces. The forces should be equal but opposite. They should be parallel but not at the same point. Yeah, there should be a distance between them. Then what is produced is called a couple. A turning effect is produced, and that is a couple. And state the SI unit of moment of couple. Couple is again defined as force, yeah, times the distance between them. Again, Newton meter. Unit comes out to be Newton meter. Okay, let's solve a few more questions. A uniform meter scale is an equilibrium as shown in the diagram. Calculate weight of the meter scale. It's a uniform meter scale. What do you mean by uniform? Uniform means the center of gravity will be at its center. This is the center of gravity. Weight. And it is at the 50 centimeter mark. Calculate weight of the meter scale. They want us to calculate the weight of the meter scale. How do we do it? They are saying that the scale is in equilibrium. So all the torques, the summation should be 0. So the torque due to 40 GF is producing a anti-clockwise turning effect. The force is, the torque is 40 GF into this distance. What distance? Distance between this distance, right? Distance between the force, line of action of force, and the point of rotation. What is this distance? From here to here is 5. From here to here is 30. So this distance would be 30 minus 5, which is 25 centimeters. Anti-clockwise means positive. Correct? Plus, what is the second force acting on it, on this body? The weight. The weight is also producing a turning effect. So, turning effect is W, weight, force, into distance. What distance? Distance of line of action of force to the point of rotation. This distance. What is that distance? From here to here is 50 centimeters. And from here to the pivot is 30 centimeter. So this distance remaining is 20 centimeters. So W times 20 centimeters. But it's producing a clockwise turning effect. So it is negative, equal to 0. Since the bar is in equilibrium. Go on to solve it and you will find out W, that is the weight of the meter scale, turns out to be 50 GF. Quite a simple calculation. We are using the principle of moments, right? What does principle of moments say? Sum of anti-clockwise moment is the sum of clockwise moment, or equilibrium means sum of all the torques should be 0. Which of the following options is correct to keep the ruler in equilibrium when 40 GF weight is shifted to 0 centimeter mark. Okay, what they are trying to say is, now what we do is we shift the 40 GF force to the 0 centimeter mark. It is no longer here. What happens? F is shifted towards 0 centimeter, or F is shifted towards 100 centimeter. When will the ruler be in equilibrium? Yeah. So the weight is what counteracts the anti-clockwise moment produced by the 40 GF force. Yes. Now, initially when the 40 GF was 25 centimeter away, the weight was 20 centimeter away because it was at the midpoint. Right? Now the distance between 40 GF and F has increased, which means the anti-clockwise moment, the magnitude has increased. I'll repeat, the anti-clockwise moment's magnitude has increased, which means the clockwise moment's magnitude should also increase to keep the meter scale in equilibrium. So F should shift leftwards. F should shift leftwards. Only then the distance between the line of action of force and W will increase. Yes, so F is shifted towards 0 centimeter is the correct answer. This is how you have to think. Yeah, when will the meter scale be balanced? That's all. Name the unit of physical quantity obtained by the formula 2k by v square. Achha, we know that kinetic energy is half mv square. So k 2k by v square turns out to be mass. Yeah, so physical quantity is mass. If you don't recall it, no problem. We'll revise it again in work power energy. A half meter rod is pivoted at the center with two weights 20 GF and 12 GF. So it is pivoted at the center. Half meter scale means the length is 50 centimeters. And there are two weights acting 20 GF and 12 GF. Suspended at a perpendicular distance of 6 centimeters and 10 centimeters respectively. Which of the two forces acting on the rigid rod causes clockwise moment? Oh, such a simple question. Which is the one causing clockwise moment? There are only two forces, right? 20 GF and 12 GF. Let's analyze both. Let's analyze the 20 GF. Which is the point of rotation? Where does the body rotate about? It is the pivot or the fulcrum, this point, right? So 20 GF is producing a anti-clockwise moment. It wants to rotate the half meter rod anti-clockwise manner. On the other hand, 12 GF is a force which wants to rotate the half meter rod in a clockwise manner. So the answer is the 12 GF force. Is the rod in equilibrium? For that we have to calculate each of the torques. So torque, there are only two forces. Torque due to 20 GF force is force 20 GF into distance is 6 centimeter. Again, the distance is from the force to the center of rotation. This is anti-clockwise, so positive. Torque due to 12 GF is force times distance is 10 centimeter. But it is clockwise, so it is negative. Yeah. So what is the resultant torque? Summation of all torques. It will be 120 GF centimeter plus torque due to 12 GF is minus 120 GF centimeter. Is which turns out to be 0. Yes, so 120 minus 120 is 0. Yes, the rod is in equilibrium. For equilibrium, the resultant of all torques should be 0. The direction of 20 kgf force is reversed. The direction of this force is now upwards. What is the magnitude of resultant moments of the forces on the rod? Yeah. So if the magnitude of 20 gf force is reversed, it becomes a clockwise moment. Yeah. So in this case, torque due to 20 gf will be what? 20 gf into 6 centimeter, but negative. Yeah. So the resultant torque in that case would be torque due to 20 gf upwards, which is clockwise. So negative 120 gf centimeter, plus torque due to 12 gf, which is also clockwise. So minus 120 gf centimeter. So minus 240 gf centimeter. I hope it is clear. Yes. If not, please pause the video, think about it, go back and rewatch it. It will be clear. It is something very simple and what we have been doing again and again throughout this video. Okay. This is a question which has repeated twice in ICSE until now. Yeah. So in the recent 5 years, a brass ball is hanging from a stiff cotton thread. So there is a thread and there is a brass ball. So it is hanging from somewhere, right? So this is a neat diagram. Draw the diagram very neatly. Yeah. That adds a plus point to your answer sheet. Draw a neat label diagram showing the forces acting on the brass ball and the cotton thread. So what are the forces? What are the forces on the brass ball? Yeah. So this is the brass ball. The forces are, number one, its own weight. Weight of brass ball. Second is the tension due to the cotton thread. Tension due to the cotton thread, and they are balancing each other, which is why it's at static equilibrium. What are the forces in the cotton thread? In the thread, there is one force called the tension. Yeah, tension. Very nice. The distance between two bodies is doubled. How is the magnitude of gravitational force between them affected? We know that the magnitude of gravitational force is what? G m1 m2 upon r squared. They are saying the distance between the two bodies is doubled. R becomes 2r. So this is case 1. In case 2, force due to gravity in case 2, case 1 is what? G, same mass, gm1 m2, but the distance is 2r squared. If you compare it, you will find that the gravity, the force due to gravity in case 2 is 1/4 of force due to gravity in case 1. It's very simple. Just the distance is doubled, right? So just take the ratio and this is what you get. It's very simple. Do it yourself. Do it yourself. Yeah, this will improve your analytical skills, your algebraic skills also. A uniform half meter rule horizontally on a knife edge, and they are saying draw a diagram of the arrangement. Very nice. So this is the half meter rule. Uniform. Uniform means half meter, as in it starts at 0 centimeter, ends at 50 centimeter. Uniform means the weight acts from where? The 25 centimeter mark at the midpoint. Yes, is kept horizontally on a knife edge at 25 centimeter. So this is the knife, and this point is 29 centimeter. Yes, when a weight of 20 gf is suspended from one end, draw a diagram of the arrangement. It should be clear to you that, okay, now there are two options. 20 GF can be suspended either on the left end or the right end. What do you think? Which end should the force be suspended into? It should be suspended into the 50 centimeter end. Why? To produce equilibrium. If it is suspended here, what will happen? Both the moments are anti-clockwise, and the meter rule will turn. But if it is suspended from the 50 centimeter mark, we will produce a clockwise torque, which will counteract the anti-clockwise torque produced due to the weight of the meter rule itself. So we suspend the force here. Force is 20 GF. And it is horizontally, so it is balanced. So we can find out the weight of the meter rule. Let the weight of the meter rule be W. It's again very simple. What is the torque due to force W? W into the distance between the point of rotation. The point of rotation is the knife. And the line of action of force is at 25. Distance is 4 centimeter. Where? Anti-clockwise. How? Anti-clockwise. So it is positive. Plus torque due to 20 GF is what? It is force 20 GF times distance. What distance? From the force to the point of application or the rotation of the force. So it turns out to be 21 centimeters. But it is clockwise, so negative is 0. So the weight turns out to be 105 GF. Please check the answer yourself. Draw the diagram and what is the weight of the half meter rule. So we have identified 3 steps. Number 1, identify forces. Number 2, identify point of rotation. Where is it rotating about? Number 3, if in equilibrium, what do? Resultant torque should be 0. These are the fundamental 3 rules with which you can solve any question. Next, a stone of mass m is rotated in a circular path with a uniform speed by tying a strong string with the help of your hand. Answer the following questions. So there is a stone tied to a string and it is rotated. Is the stone moving with a uniform or variable speed? The answer is given in the question itself, with a uniform speed. So uniform is the answer. Number 2, is the stone moving with a uniform acceleration? Is it? No, it is a non-uniform acceleration. Why? Acceleration is a vector quantity. At every point, the direction of motion is changing, right? So there should be a force acting on it. There should be a force acting on it, and the direction of force is changing at every moment. It is always towards the center. So here it is this way, here it is this way, at this point it is this way, always towards the center. So direction of force is always changing. Hence, by F equals me, direction of acceleration is always changing. So it is not a uniform acceleration. In which direction does the acceleration act? It always acts towards the center. It always acts towards the center. Centripetal force, right? It's centripetal force always acts towards the center. What kind of force acts on the hand and state its directions? So on the hand, if this is the hand, you will feel a pull. You will feel a pull away from the center. that is caused by the tension in the string, which is equal to the centrifugal force. Remember, centrifugal force is a unreal force, fictitious force, which exists only in a rotating reference. Only if you sit on the hand, you can feel the centrifugal force. Yeah. So what kind of force acts on the hand? It is tension, which is basically the centrifugal force, and it acts radially outwards, away from the center. It acts away from the center. Yeah, this is the same question repeated. Okay, if a body is placed on a tabletop, it exerts a force equal to its weight downwards on the tabletop, but does not move or fall. Okay, fine. It's at in equilibrium, right? Name the force exerted by the tabletop. The force, this is the, from the side view. This is the table. This is the book. Yeah, this is the body. There is a weight acting downwards, and there is a normal reaction force N applied by the table on the body. So the name of the force is the normal reaction force. Normal reaction force. What is the direction of the force? It is vertically upwards. What? It is vertically upwards. Yeah. Great. On what factor does the position of center of gravity of a body depend? We already discussed it. Center of gravity depends upon two factors. Number one, shape, or it depends upon the shape. Second, distribution of mass. Center of gravity depends upon number one, shape, and number two, distribution of mass. Great. What is the SI unit of moment of force? We have done it twice today. Please go over the previous slides. Name two factors affecting the turning effect of a body. Yeah, it comes from the definition of torque. What are the two factors? Torque is defined as force times distance. Distance, you know what distance, right? Distance of the line of action of force to the point of rotation, right? So name the two factors. Number one is force itself. Lesser the force, lesser the turning effect. Greater the force, greater the turning effect. Second is the distance of the line of action of force to the center of rotation. So these are the two effects, the two factors affecting the turning effect of a body. Define equilibrium. Equilibrium is, it's the state in which a number of forces are acting on the body, yet no change is produced in the state of rest or of uniform motion. Then the body is said to be in equilibrium. I repeat, when a number of forces are acting on the body, yet no change in the state of what? State of rest or of uniform motion. No change, then it is called equilibrium. In a beam balance, when the beam is balanced in horizontal position, it is in what equilibrium? Tell me. There are two kinds of equilibrium. Static, yeah, when forces are applied yet the state of rest is not changed, then it is static equilibrium. Second is dynamic, when a lot of forces are acting yet the body remains in a state of uniform motion. That is called dynamic equilibrium. So in this case, the beam is in static equilibrium because the beam balance is in rest. Beam balance is in rest. So static equilibrium. Okay. Force is applied on number one, non-rigid body, and number two, rigid body. How does the effect of force differ in the above two cases? Okay. A rigid body means a force is applied and its dimensions do not change. Non-rigid body means force is applied and its dimension changes. Yeah, just like when a mud is turned into an idol. Yeah, force can change the shape of the mud to produce a beautiful idol. So the mud is a non-rigid body. Yeah, so how does the effect of force differ? It differs. In a rigid body, there is no change in dimensions. In non-rigid body, there is a change in dimensions. Very nice. That is the primary difference. Number two, a metallic ball is hanging by a string from a fixed support. Yeah, this is the same question as that. Yeah, a brass ball hanging from a cotton string. Same question. Draw a neat label diagram showing the forces acting on the ball and the string. There is a weight acting, there is tension. Weight of the brass ball acting downwards, tension pulling the ball upwards. What is the weight of the body placed at the center of the earth? Okay, this is a very interesting question. Yeah, the force, the formula is Newton's law of gravitation is G m1 m2 upon r square. So at the center of the earth, what is r? R is the distance from center of the earth to the body, or the distance between m1 and m2. Yes, so here m1 is earth, m2 is us. If the body itself is placed at center of the earth, what happens? R becomes 0 or R tends to 0. Our weight will become infinite. We will weigh infinity. Yes, we will weigh infinity. Is it possible to have an accelerated motion with a constant speed? Yes, we definitely can have it. And the answer is in a uniform circular motion. When you are in a uniform circular motion, your direction of motion changes at every instant. So there must be a force acting on the body towards the center, which is called the centripetal force. And that centripetal force produces an acceleration, correct, even though the speed remains constant. So yes, it's possible. Okay, now there are a set of a few interesting questions that I found, yeah, with respect to the first chapter. Yeah, so I would like to call this section called the challenger section. It would require you to think a bit. Yeah, so let's get on with it. Let's see how it goes. On a seesaw, two children of weights 30 kg and 40 kg are sitting on one side of it at distances 3 meters and 4 meter respectively from the fulcrum. Yeah, so we have a seesaw. Let's say this is the seesaw. Yeah, the fulcrum of a seesaw is always placed at the middle. Yeah, they are saying there are two children of weights 30 kg and 40 kg. So there is one person here, two kids. Yeah, so this is 30 kg, 30 kg mass, and the question is framed a bit differently, wrong, bit. It's not weight, it is mass. Yeah, 40 kg. The distance is 3 meters and 4 meters from the fulcrum. Where should a man of weight 75 kg sit to balance it? It is clear that the man has to sit somewhere on this side. Yeah, because both these boys are producing a anti-clockwise turning effect. So the man will have to sit on the other side of the fulcrum. Somewhere here, let's say. The weight is 75 kg. And I want to find out where he should sit. Let this distance between the fulcrum and the force be x. Yeah. So the torque due to 30 kg boy is force, which is the weight, 30 kg into g, G is the gravitational force into distance 3 meters anti-clockwise, so it is positive, correct? Torque due to 40 kg is 40 kgs into gravity into distance 4 meters anti-clockwise, it is also positive. Torque due to 75 kg person is 75 into gravity, that is the weight, into the distance, which is x, distance of the line of action of force and the point of rotation. This is negative, yes, because it is a clockwise turning effect. Now if it is balanced, if the seesaw is balanced, sum of all the torques should be 0. So 90g plus 160g minus 75gx equals 0. So 75gx equals 250g, g cancels out, x will be 50, 25, 50 times 25, 3 times, 25 upon 3 meters, 50 upon 3 meters, x is 50 upon 3 meters. So the 75 kg man should sit at a point 50 over 3 meters to the right of the fulcrum, or the opposite direction, opposite side of the two kids, of that of the two kids. If it is not clear, please rewatch this question. Second question, a uniform meter scale balances horizontally on a knife edge placed at 55 centimeter mark when a mass of 5 gram is suspended from one end. We have done an exact same question, just the values are different, 55 centimeter and 5 gram. Yeah, we have done the exact same question that has come in board examination. Let me show you. This is the exact same question that has come in board examination. Identify the forces, identify point of rotation. If in equilibrium, make the resultant torque 0. Yes, so this would be a nice way to test your knowledge. Try to solve this question yourself. Yeah, yourself. Okay, a uniform meter scale is balanced at 40 centimeter mark when weights of 25 gf and 10 gf are suspended at 10 centimeter mark. Yeah, so this is the 10 centimeter mark and 75 centimeter mark. So from the left, this is 75 centimeters. Calculate the weight of the meter scale. Acha, where will the weight act? It's a uniform meter scale. So for a uniform body, center of gravity of a rod or a meter scale is at its midpoint. Let the weight be W. Yes, let's calculate the torque. Since it is balanced, the resultant torque should be 0. What are the forces? Let's identify the forces. The force is 25 gf force, weight of the body of the meter scale, and 10 gf force. Yes, what is the point of rotation? The point of rotation is the fulcrum. Yes, it is balanced at 40 centimeter mark. So 40 centimeter mark, we have the point of rotation. Let's write torque due to 25 gf force is force 25 gf into distance. What is the distance? Distance between the force and the axis of rotation, this distance, and this distance turns out to be 30 centimeters. 40 from here to here, 10 from here to here, so this to this is 40 minus 10, 30. Anti-clockwise, so positive. Similarly, torque due to 10 gf is 10 gf force times distance. What distance? Distance of the force from the axis of rotation. So from here to here it is 75. Here to here is 50. So here to here is 25 centimeters. Now it is clockwise. It tries to rotate the body clockwise, so it is negative. Torque due to weight of the body is force times what? The distance of the force, the weight to axis of rotation, this distance. From here to here is 50, here to here is 50, here to here is 40. So this distance is 10 centimeters. 10 centimeter clockwise, so negative. Now sum of all the torque should be 0. Yes, because the meter scale is balanced. So sum it up. 750 GF centimeter minus 250 GF centimeter minus 10 W centimeter is 0. So W turns out to be 50 GF. Yes, I hope it is clear. If it is not, please go over this question again. It's a very simple question. Just a few steps have to be followed and the answer is attained. Last few questions. Okay. The wheel shown has a fixed axle passing through O. The wheel is kept stationary under the action of forces, two forces, F1 and F2, such that horizontal force at F1, this is horizontal, and a vertical force at F2. Show the direction of force F2 in the diagram. Yes, okay. Now force F2, they just have said it is vertical. Where should it be? The point of rotation is O. Yes, the body rotates about the point O. If it is balanced, if it is stationary, then there should be no moments. So if the force is acting, F1 is acting to the right, F2 has to act downward. If it is acting upward, what will happen? Both these forces will produce a clockwise moment. Yes, and we cannot have equilibrium. So there are two cases. Number one, force 1 is acting to the right. At that point, F2 has to act downwards. Second case, if F1 acts to the left, F2 at this point should act upwards to counteract the balance. Yes, I hope it is clear. Which force is greater? Which force is greater? Now, let's take this to be our case. Yeah, the moments, let's calculate the moment. Torque due to F1 is what? Force into distance. What distance? Distance of line of action of force to the axis of rotation. So this distance, right? OP is given to be 5 centimeter. It is 5 centimeter into 5 centimeter. Torque due to F2, and this is clockwise. Torque due to F2 will be force F2 times the distance. What distance? Distance of force to the axis of rotation. So this distance, and this is given to be 3 centimeter. 3 centimeter anti-clockwise. So which is greater? Now if it is balanced, if the force, if the torque, if the axle is balanced, the wheel is balanced, total torque should be 0. So F1 into 5 centimeter minus, because it is a clockwise torque, plus F2 into 3 centimeter should be 0 since it is in equilibrium. So this will give you one formula. F1 by F2 is 3 by 5. which means what? F2 is greater than F1. The second force is greater than first one, which is very logical. Yeah, F2 is closer to O than F1. Yes. Now, to produce the same but opposite torque, so the magnitude of force remains the same. This is the same. Distance has to change, right? So distance is larger for the first case, F1 case. The torque is same. Force we want to find out. Distance for the first is same. Correct? So the distance for the first is larger. So the force of the first one should be lesser. Yes or no? If it is clear, or if it's not clear, please go through it again. It's a very simple question, but makes you think. Wheel shown has a diameter 3 meter with axle at O. Force 0.5 kgf is applied at P in direction as shown. Calculate a moment of force about center O and point Q. Very nice. This will clarify your doubt, if you have any, on the point of rotation. First is what you identify the forces. What is the force acting? Force is 0.5 kgf. It is applied at point P. This is point P. Calculate moment of force about center O. Okay, I want to find out torque about O, which is force. What is the force? 0.5 kgf times the distance. What distance? Distance from the line of action of force to the point of rotation. So this distance, OP, times OP. So what is OP? Has a diameter 3 meters. So the radius will be 1.5 meters. OP is the radius, right? Turns out to be 0.5 into 1.5 kgf meter. Yeah, so 0.75 kgf meter. What sense? In clockwise sense. Clockwise. So negative. Right? Torque about point O. Torque about point Q means Q is the point of rotation. So the force is same thing, 0.5 kgf times what distance? About point Q. So this is the distance we are concerned about. D is the distance from the line of action of force to the point about which the torque is being calculated, to the point of center of rotation. Yeah, so for this case, center of rotation is Q, because they have asked moment of force about Q. So the distance is 3 meters. 3 meters, it is clockwise, so negative. So this is the answer. About point O is minus 0.75 clockwise, minus 1.5 clockwise. There is a guy Puneet, and he tied a small pebble at one end of a string which is placed near the periphery of a circular disc, at the center of which other end of the string is tied to a peg. The disc is rotating about an axis passing through its center. What are the observations when Puneet is standing outside the disc and when he is standing at the center of disc? Yeah, if you're not understanding, pause and read the question again. Read the question again. So there is a disc. And the disc is rotating about its own axis. It's rotating. What did Puneet do? He took a stone and he tied it here using a string and brought the string to the center of the disc. So the disc is rotating, and with it stone is also rotating. Yes, so this is the scenario. This is the disc. Now they're asking two questions. Number one, Puneet is standing outside the disc, somewhere here. Puneet is standing and he is watching. When you watch from outside, what will happen? You will see that the string will be taut and the stone is also rotating with the disc. Yes, which means a uniform circular motion is happening. A circular motion is happening for the stone. Yeah, there is a force that the string puts on the stone inwards towards the center of the circular path. That is what Puneet will see when he is standing outside. Yeah, what if he is standing at the center? He is here in the center, second case. What will happen? He will see that there is a force which is acting on the stone, yeah, having a pushing effect on it, pushing it away from the center. Yes, you will see the tension force, tension force pulling it in, pulling the stone in, and a tendency of the stone to fly away. If the string is cut, the stone will fly away from the center, and that force is centrifugal force. Centrifugal force will be visible to Puneet only when he is standing in the center. If you have any doubt on this, please contact me or mention in the comment section. Yeah. If you have doubts, you may also go and visit the previous lecture on centrifugal and centripetal force. It is something very common. If you just close your eyes and visualize the situation, what is happening? Yeah, what is the question trying to say? You'll be able to form your own answer. Okay. In a given figure, there are three forces A, B and C of magnitude 5 Newton. So all three have the same magnitude, 5 Newton, 5 Newton, 5 Newton. Point O lies in the same plane. Which force has the greatest moment about O? Okay, moment about A. See, all the forces are same. So what will determine the distance? We know, right? The torque is what? Force into distance. Force is same. So distance, right? Greater the distance, greater is the torque, right? And we want maximum torque. So we want a force with maximum distance. Distance of what? Line of action of force to the center. Here the distances have been mentioned: 0.9 meters, 0.8 meters, 0.6 meters. Which is the greatest? 0.9 is the greatest. So which force is the greatest moment? A. A has the greatest moment. Name the forces producing clockwise and anti-clockwise moment. Yeah, so O is the axis of rotation, right? So you can see that force A and force B is producing a clockwise. Clockwise is forces A and B, and anti-clockwise is force C. Yes, it is something very common, very easily visualized. O is the point of rotation and C is trying to rotate it anti-clockwise. Very nice. What is the resultant torque about point O? There are three forces. Torque due to A is what? 5 Newton into 0.9 meters into, which is clockwise, negative, right? Torque due to point B is 5 Newton times 0.8 meters clockwise, so negative again. Torque due to C is 5 Newton into 0.6 meters anti-clockwise. It is positive. So resultant torque is what? Summation of all the torques. So torque due to A plus torque due to B plus torque due to C turns out to be 5 Newton minus 5 Newton into 0.9 meters plus 0.8 meters minus 0.6 meters. Very easy to calculate. And we get the resultant torque resultant to be 5 minus 5.5 Newton meters. Yes, check it yourself and please solve it yourself. It's a very simple question, but gives you an understanding of clockwise and anti-clockwise movements and how to compare. Yeah, if given such a situation, how do you know which force will produce the maximum moment? Great. There is a one last question which I found to be very interesting, which is there is a stair. There is a stair. And there is a roller or there is a ball or whatever. It is on the lower step. And I want to take this roller or ball or whatever to the upper step. They are saying, number one, where should be the minimum force applied? Yeah, question is, where should the minimum force be applied? First of all, where should the force be applied? Okay, how do you want to take it to the upper step? Is by rolling it. Yeah, so we apply a force maybe in this direction, and we want eventually that this circular object, this roller, rolls and it eventually comes to the upper step. I hope the visualization is clear. So you must notice that x is the point of rotation because x will be in contact. Yes, so when I apply the force, this roller rolls about point x and eventually comes to the upper step. Something like this. It comes to the upper step. Yeah, so where should the force be applied? Yeah, there's a turning effect of force, right? Again, the force is turning the body, rotating the body about point x. So torque we know is force times distance. Distance we want it to be maximum. So maximum force means the distance should be maximum. So the maximum distance that can be achieved in a circular geometry is at a diametrically opposite point. So x is here, so a diametrically opposite point should be considered here. Let's call it point P, and the force should be applied here. In what direction? It should be tangent. Why? This is a question for you. Yeah, F1, let's say there is another force in this direction, F2, and another force in this direction, F3. Yeah, remember the first question we solved? Draw the line of action and find the distances. Yeah, find the distances D2, D3 and D1. Yes, in this case, in which the force is perpendicular to the distance, the diameter or tangent to the circle, we get maximum D1 or maximum torque. Yes, that is the reason the force has to be applied perpendicular to the diameter, tangent to the circular cross section. How do I find this point P? It should be diametrically opposite to the point of rotation, which is x. Yeah, so this is a very interesting problem, which is very simple if you apply your common sense. If you visualize an object rotating or moving or rolling up a step, this becomes very easy. This becomes very easy. I would invite all of you to try to solve this problem on your own. If you have any questions, please feel free to contact me through the comment section, or if you are my students at Boon School, please come and talk to me regarding this. Yeah, thank you for listening to me. So this video contained the ICSE questions of the last few years related to the chapter force, and a few more challenging questions. There is nothing a challenge for you if you work hard, if you understand the concepts clearly. I know that. Yeah. Best of luck to you and see you in the next chapters. Thank you so much.